Okay, so we just have one theorem and one little thing here, and then the rest is basically just like examples that we're going to do. Oh, so that root of a product theorem says for any non-negative real number, so just basically positives and zeros, x and y, and any integer, n is greater than or equal to 2, so basically just not 1, not 0, no negatives. They give us two different things there. So they give us the power form and the radical form. Power, remember, is like the exponents. Radicals is where we've got like the square root thing. Basically, they just kind of break it down where, like, if you've got, something like x times y to the power of something, we remember that we can split that up where, so like they've got it as, well, they got x, y to the power of 1 over n, oops, not 2, n. They just break it as x to the 1 over n and y to the 1 over n, okay? And that's just in the book there. I just copying that down. But yeah, basically they're just saying you can break it up into two different ones, and then same thing if it's like the root there or whatever. So like if you have got the nth root of something, you can do the same thing where you break it into two of that root, just like the x and the y separate, okay? And some of our examples we do are going to be kind of based on that. So most of the examples, what they're going to ask you to do is they're just going to give you something and say like simplify it or like get it down to like its base or something like that. When they ask you to do that, what you want to do, so it says when simplifying, always take out from the under the radical as much as you can, okay? So like here, we've got some stuff under radicals. We're going to break these down as far as we possibly can. Sometimes they're going to come out nice. Sometimes stuff is going to be left underneath the radical sign or under that root sign, okay? And I'll kind of show you some options of both, okay? So when we get a problem like this, technically there's kind of a couple ways to go about it. So we know from our last quiz yesterday that we're going to have to learn how to do this stuff by hand, right? Just to kind of show it. And another reason we got to kind of learn how to do it by hand is we're going to do some in a little bit here that have letters in them. And we know if they've got letters, we can't just use our calculator. So I'm going to show you two ways to do some of these. So like here, if I've got square root of 20, if it's just no number in there, we know that's like a little 2 in there, right? So it's not there, but we know that's a 2. So what we want to do is we want to take here and do our prime factorization just like we were doing before. So we're thinking, okay, what numbers multiply together to be 20? So what's something that multiplies to be 20? Well, if it's even, what always works for our evens? 2, right? So we could go 2 and 10. Once we get a number like this where it's like a 2 or a 3 or a 5 or something like that that are our prime numbers, you remember we circle them because we can't go any further. And then 10 we could keep breaking down, right? Because what would 10 break to? 2 and 5, right? And with both of those, aren't both of those prime? Should be, right? So that would be as far as we can go, breaking it down to our primes. So then what we do is we take all of our numbers there that were our primes that we broke down to, and I always just write it as 20 is equal to, because that's kind of the number we were breaking down. And it would be like 2 times 5. And then what you're doing is you're always taking whatever our root value was here, so the 2, and you're breaking this up into groups of 2, okay? So here, we've got 2 of the 2's, so that would be like a group of 2, right? With the 5, can that be grouped up, or is it just by itself? Just by itself, right? So here, this is a little different than what we've done before, because the only ones we can group together are those 2's. So what you would do is you would take that thing that you grouped together there, the 2's. We can do the root of that, because the square root of that, because that would be like 2 times 2, because the square root of 4 is 2. So that would give us, go back to the pen here, that would give us 2. Now here, I want you to write like a little arrow. If this can't be grouped up into the proper grouping size here of like whatever that root was, it's going to stay under that root. So I'm just going to write stays under root, or you could put stays under the radical, because it couldn't be grouped up in that like group of 2. Does that kind of make sense? So here, that could be grouped up, so that goes outside of it, but since that can't, that stays under that square root. So that would simplify to 2 square roots of 5. Okay, cool on that? Now technically, if I was doing this out myself, I would recognize here, and you don't have to write this one if you don't want to, but I'm going to show you another version of this. if I'm doing this myself here and I'm trying to break this down to 20, what I would actually break to first is I would break to 4 and 5, because here, if I break these down, what is the square root of 4? 2. So if I thought of it as square root of 4 and square root of 5, and I know square root of 4 is 2, and square root of 5 wouldn't break, wouldn't that get me down to the same thing? Yeah, so if you can recognize that and know how to do that, that's another way to do it. But like I said, if that gets too confusing for you, this way will work all the time. This way will work as long as you know what you're doing, okay? But this is a foolproof way of doing it, okay? All right, let's try another one here. So this one we gotta be a little careful on here, because this one, third root, right? So when we're making our groups, we want to group them in threes. So we could start the same way, break down our 64. So what's something that multiplies to 64? And it can be anything. We can do 2's because it's even, or we can do whatever number we want, doesn't matter. You want to just do 2's because it's even again? Sure, okay, so if we go 2's, we can go 2, and then half of 64 would be 32. 32 is even again, right? So we could go 2 and 16. 16 is even again, so 2 and 8. And then 8 is even again, 2 and 4. 4 is even again, 2 and 2. Follow me on that? Or like, you know, maybe when you got to the 16, maybe you broke it 4 and 4, but then 4 and 4 would still break down to all those 2's. No matter which way you break it, it'll always end up the same. Okay, so then what we want to do is we want to count up all those primes. So it looks like we got 1, 2, 3, 4, 5, 6 of those 2's. So 64 would be equal to 2 multiplied out 6 times. Then when we go to do our grouping, again, our groups are based on the size of this root here. So if this was the third root, we're looking for groups of 3. And in our case here, we actually have 2 of those groups of 3, right? So we got 3 of the 2's and then another group of 3 of the 2's. So then what you got to remember here is if we've got 2 different sets of it here, we take one thing from here, one thing from here, and we multiply those. So it would be like a 2 from this group, 2 from this group, and we multiply. So it would end up kicking us out a 4 on that. And then there was nothing left over, so just the 4. Okay, try another one here. Let's jump down to C. So again, we got cubed root again there, and we got 40 that we're breaking down. Okay, 40, what are we thinking breaks to? 4 and 10 works. And then neither of those are prime, so we keep breaking those. So 4 would go to 2 and 2, which is good because both of those are prime. And then our 10, well, 2 and 5. And that actually works out pretty slick for us, right? Because aren't all those primes at that point then? Would be, right? So then we do the same thing where we write our stuff all multiplied out. So 40 is equal to, we got 3 of the 2's. And then that extra 5 back there. And again, we want to pay attention to what size of groups we're making. So it's cubed root, so we're making groups of 3. So looking at those 2's, looks like that can be broken into a group of 3. And then this one's kind of similar to that one we had before. If there's something that's outside of that grouping that doesn't have other ones to group up with, I'm just going to write my note again that it's going to stay or stays under my root again, because again, I can't make a group of 3 with that. Even if there was 2 of them there, it still couldn't group up to the 3. So then, because this made a group, that can go out front by itself, the 2. And then the 5, like I said, can't be broken down any further and can't be grouped up. So here the 5 would stay under the root. And be careful here, because our root was 3. So that means that root is 3. So it would be 2 times the third root of 5. And you can always go back and double check yourself. If you did this out on your calculator, 2 times 5 to the 1/3, and then did 40 to the 1/3, it should be the same exact decimal number. So you can also kind of check yourself out that way as well. Okay, and then the last one here. So we got 32 we're breaking down, and our root this time is 4. So just pay attention to that. Okay, so if I break 32 down, what do you think? 16 and 2 works. That was the one I heard first. So 2 is prime. 16 could go to 8 and 2 would work. 2 is prime. 8. 4 and 2. And then 4, 2 and 2, right? Okay, so then we do the same thing. So write our stuff out here. So it'd be like 32 is equal to, it looks like 1, 2, 3, 4, 5 of those. And then the root value we had was 4, so we can only make groups of 4 here. So that would be a group of 4. Then we got that leftover guy there, right? The 2, so that's going to stay under our root. Okay, so we got that 2 that can be grouped up, so we'll pull that out front. And then this guy's got to stay underneath our radical there. So we'll leave the 2 under there, and then be careful because our root was 4. So 2 times the 4th root of 2. Okay? Okay, so like I said, I just wanted to do those because I know it can be kind of tricky to break that stuff down. The next stuff is all going to be in our packet. So grab your example packets out. And all of the final stuff here is in the packets. Okay, so these are all similar type problems, but like I said, it's going to kind of mix in the stuff where it's like multiplying these things, but I'll kind of show you what to do on this. Okay, so it wants us to figure this stuff out without the calculator, so again, when we do that, we just got to show our prime factorization in those factor trees, right? So here what we can do, it's kind of like the opposite of like what we had here. So like if we had something like this and we had like 2 roots here of the same thing, like an x and a y and of the same root, we could take those and combine those together with multiply. Same thing can happen here because if these are both to the 3rd root, what we can do is we can combine together the 320 and the 25. So if you multiply 320 and 25, it should be 8,000. And if you needed to use your calculator on that just to break that down, that's, to get that multiplied out, that's fine. I get that. The main stuff I want you to show work on is the breaking down. So now we've got this cubed root of 8,000. So what I would do is I would just start breaking this down here. And I got that because I multiplied those 2 together. So I would break down my 8,000 then. So an easy one to me, if it's 8,000, wouldn't 8 times 1,000 give me 8,000? Yeah, right? So that would give me an easy one to break. You could do by 2, but that might take you a little bit longer to kind of break some of that. And then we know 8 could go like 4 and 2 like we've kind of had on those previous ones. 2's prime, 4 down to 2 and 2. And then with the 1,000, again, we could keep breaking it by 2's, or what you could think is you could think of like bigger numbers that multiply to 1,000. So I'm thinking if that's got like 3 zeros, I'm thinking like 10 and 100, because 10 would have 1 0, 100 would have 2 zeros. So I'm thinking that could go down to 10 and 100. And then that gives me a little bit nicer numbers to break, because then 10 can go to 2 and 5, which would both be prime. And then 100, what do you want to break 100 to? 10 and 10 works for me. And then we know 10 and 10 could go to 2 and 5, 2 and 5. And again, no matter which way you go, like if you went with 100 and you went like 4 and 25 or 2 and 50, you would still get all of those same numbers, okay? Okay, so then we write it out as our prime factorization deal here. So we would go 8,000 is equal to, looks like I've got 1, 2, 3, 4, 5, 6 of the 2's. And it looks like 1, 2, 3 of the 5's. Then when we do our groups, again, we want to pay attention to what our root was. So it's the 3rd root, so we want to make groups of 3. So 3 2's, another 3 2's, 3 5's. So those actually worked out pretty well because we don't have any leftovers there. So then you just take one thing from each of those groupings and you multiply them together. So you pull a 2 from there, times a 2 from there, times a 5 from there. And then you just multiply all those together. So 2 and 2 is 4. 4 times 5 would be 20. So the cubed root of 8,000, or that stuff multiplied, would end up being 20. Okay. Next one here, they mix in some letters, but it's the same concept. So it wants us to perform the multiplication of where we've got the 5th root of 8x squared times the 5th root of 4x to the 8th. Okay, so I would start there again by grouping my stuff together. So I think I'm going to rewrite it down here, actually. So if I've got 5th root of 8x squared times the 5th root of 4x to the 8th, what I'm going to do is I'm going to group this all together and just make it 1/5 root. And I'm going to group together my 8s and my 4, because those are both just regular numbers, so I just treat that as multiply. So 8 times 4 is 32. And then I'm going to do the same thing with my x's. So if I had x squared and x to the 8th, do you remember what we do when it's like x squared times x to the 8th, what we do with the powers? Add them. So when you have power of power, you multiply. When you are just multiplying powers, we get 2 of them here, 8 of them here. So that would be like x to the 10th. Okay? So kind of got it a little bit simplified here. But now we're doing the 5th root of both of those things. So then what I do is I break it even further and I go, okay, well, I got a regular number there and I got an x there. So I'm going to do the 5th root of both of those separately. So I'm going to break it to the 5th root of 32. And the 5th root of x to the 10th. And then the ones with the variables are just similar to what we've been working on, because if this is 5th root and that's x to the 10th, 5th root means like 1/5, right? So here, if we switch this to x to the 10, because that would be like kind of our regular power number there, and then our root value would go on the bottom. You remember doing that from the other day? So we can kind of put that together. And then here, if we're going to break this down, we would just do like we were doing before with our factor tree. So like 32 could go down to 2 and 16. 2's prime, 16 could go like 4 and 4. The 4's could go both down to 2 and 2. So then that would be 1, 2, 3, 4, 5 of the 2's. And that's what we were grouping by, so that works out pretty well because we were grouping by 5. So then that would be just 2 left there for that, right? So then that would go up in here, because that would be what our 5th root of 32 was, is 2. And then there's just one more thing we could do here with our x to the power of 10/5. Wouldn't 10/5, if we divide that out, wouldn't that just be 2? Should be, right? So then that would be still 2 out front. X to the 10/5. 10/5 is the same as 2. That'd be the same as x squared. Okay? Kind of a lot of steps, but it's all stuff we've been working on. Okay, a couple more here. Okay, so this one they've got already put all together for us, so that's good. So we're just doing the root stuff on it then. So here I'm just going to, again, kind of rewrite it down here. Cube root of 125, a to the 12th, b to the 27th. And then similar to that last one, once I'm at this point, I'm going to break it into kind of individual chunks to the 3rd root. So I'm going to break it into 3rd root of 125, 3rd root of a to the 12th, and 3rd root of b to the 27th. And then here, if we wanted to take this guy and get rid of it right away, so if we take 125 and break her down, any thoughts on 125 broken down? Think about quarters. If it ends in 25, you can divide by 25. How many quarters are in it'd be 5, right? So there's 5 quarters in $1.25. So you could have 5 times 25. So it'd be 5 quarters in $1.25. 5's prime. 25 could go down to just 5 and 5, right? So then 125 would be the same as 5, 2, 5 times 5 times 5. Groups we're making here are to the 3rd, or the 3rd root, so we're going to make a group of 3. So that would just kick us down to 5, right? And then that guy's what we're going to be using for this first part here, because that was that broken down. And then kind of similar to the last one in the last section of notes we did, if we've got a to the 12th under that root, we know that root is the same as like 1/3, so we could make this as a to the 12 over 3, because the over 3 would be like the 3rd root. Same thing with the b. You could do it to the power of 27 over, again, 3rd root would be like dividing by 3 there. And then conveniently on this one, both of those would go down nicely, because if we took 12 and divided by 3, we would get 4. So our 5 will drop down there. A will end up being 12 divided by 3 would be 4. And then with our b one there, 27 divided by 3 is 9. So it would end at b to the 9th. And then that would be as far as we could go with that. Okay, one more and then I'll leave you alone. Okay, last one here. They just want us to rewrite it with the smaller power of y inside the radical. Basically the same thing, just working, simplifying it down as much as we can. The only thing that's different about this one is it's kind of like some of the ones we were doing before where there's some stuff that has to stay under the roots. So that's why it kind of says it kind of weird there, but it's the same thing we were just working on. So if I go 5th root of 96 y to the 11th, I'm going to do similar to what I did before where I break it into 5th root of 96 and 5th root of the y to the 11th. And then off to the side here, I'll try to do 5th root of 96. So my thought probably on 96, I don't know a nice number with that, so maybe I just go 2, because it is even. And then I'd be thinking half of 96, well half of 90 is 45, half of 6 is 3, 45 and 3 is 48. And then 48, you could go 2 again if you wanted to. You can also go 4 and 12. If you knew that one off the top of your head, I'm going to go 4 and 12, but you could also go 2 and 24 if you wanted to, doesn't matter. And then since I went 4 and 12, I'm going to go 2 and 2 for the 4. 12, I think I'm going to go 3 and 4, I think. So 3 is prime, 4 we'd have to take down one step further to 2 and 2. And then that would be 1, 2, 3, 4, 5 of the 2's. 96 is equal to 1, 2, 3, 4, 5 of the 2's, and then just 1 of the 3's. So like I said, this is one where some stuff's going to stay under there, because here, if our root was 5, we want to make groups of 5. So there's 5 of the 2's, which is good, because then we can just pull a 2 down here, but similar to our one before, that 3 is kind of by itself, so it's going to stay under our radical symbol there. That's 5th root. It's going to stay under that root. So then it would be 3, and our root there we pay attention to is 5. And that's as far as we could go with that chunk. So then we would just take that and put that back up here instead of our 96. So we're going to take that to 2 to the times the 5th root of 3. And then with the y to the 11th here, it's also kind of a little bit goofy, because like if we did it out like before and we had like 11 over 5, is 11 over 5 going to divide out nice? It wouldn't. So what we can actually do on this is we can actually, because if we've got y to the 11th, isn't that just y multiplied out 11 times? So what if we took y to the 11th and kind of made it into groups? So like say I broke this into 5th root of y to the 10th and y to the 1st. Wouldn't that still be the same as y to the 11th? It would, right? And then here, if this is y to the 10th then, couldn't that split up by 5 evenly? Could, right? This guy can't, but that's okay. We just want to leave that under our thing, kind of like what we had to do here. So then what you can do, so this front part's just going to stay the same. We can break this separately here, and we can think of it as like the 5th root of y to the 10th and the 5th root of y to the 1st, or just, you know, the y under there. And then this one, like I said, can break down further because it would be the same as y to the 10 over 5, which we know is the same as y to the 2nd, right? So that could go a little bit further. And then this other guy, we know if we did like 1 over 5, can't go down any further, and they want us to leave it where the smaller power is inside the radical, so we leave it with our radical symbol there. So kind of just like that, and I was just dropping those down, kind of just didn't want to write it again. And then same with this guy here, that guy would just drop down. Oops, 5's under radical there. And then technically there's one step that you can go further than this. Because these are both roots of 5, you could actually put those guys back together so you don't have two separate roots of 5. So what you can do is you can group those guys together because they're both roots, and then you could group those guys together because they're both not roots. And you could put like the 2 and the y squared together. And then you could take both of your ones that are under the root of 5, so the 3 and the y, put those all together, and that would be the best version that you could get down to. Okay, that's pretty tricky because it's a lot of breaking down and it's a lot of messy stuff there where stuff didn't break all the way. but that would be the best answer we can get to. Okay? Okay. So that's it for that stuff. So you got the book page there, 5:48, 2 to 19 for tomorrow, and then tomorrow we'll go on to